Welcome to Programming in Modern C++. We are in week 8 and we are now going to discuss module 38. In the last module, we concluded discussions on exception handling in C++, the use of try, throw, catch, which is a very, very important feature and you must practice it a lot. In this module, I start a two-part discussion on generic programming or meta programming feature of C++. We have so far been dwelling with procedural features and with object oriented features. This is a new aspect of C++, generic programming or meta programming, that is where you can write programs in C++ which generates programs. Right? So, that feature in C++ is called template. This discussion will be in two parts. In the present module, we will talk about function template, and in the next module, we will talk about class template. So, this is the outline available on the left panel as usual. So, what is a template? Let us first just talk about that. Templates are a specification of collection of functions which are parameterized by types. Right. So far, functions were parameterized with for their arguments, but not by types. Why do we need that? Because there are several functions, several logic which are where the algorithm is generic, like search, like finding minimum, like these are generic in nature of the algorithm. But we need to write different versions of the code because there is a strong type checking in C++. Right? For every type of data for which I want to do a search, I need to have a separate function. Similarly, lot of data structures like stack, list, queue, all of these, they have the same data members, the same methods, because that is the behavior of the data structure, but they need to be written with every possible type of data element. So, stack of integers, stack of double, stack of strings, stack of complex, stack of my class, all of these will have to be written, even though the basic logic of push, pop, top, empty and all that will be the same. So, the question is, can we get rid of this redundancy and increase the reuse by writing the logic in a type independent manner. So, to illustrate, let us say we have these different types and we want to find the maximum of two numbers. So, what will be the immediate C++ solution? We can write all these functions. These can unlike C, these can reside simultaneously because of the overloading feature. So, I can have a max for int, max for double, max for char star or string, max for complex and so on. But each max function will have the same algorithm, but different code versions. So, that is a lot of overhead and lot of redundancy. So, these are the three max functions for integer, double and string. You can see that for string you need to, since you get two pointers, it is not enough to compare the pointers, you have to do a strcmp, the string comparison from the C string library and compare which string is less or smaller or is greater. Then we can with a set of values, we can call the max with a, b depending on their integer type. So, this function will get called, I call max cd, they are of double type. So, this function will get called. I can call S1, S2 char star types. So, this function will get called. Everything will work fine, but the problem is all of these have to be provided separately, and if there is a new type for which I need to do a comparison of two values, I need to write another function, even though the logic would be the same. Right. So, how can we write it in a generic type oblivious form? Naturally, one feature that comes to mind immediately is macros. Now, we have seen macros, that was the purpose that C had macros. So, what if we can just quickly recap as to what will happen if I want to use macro in this context. So, I will write a macro like this, where this is the comparison. Now, and all these lot of parentheses are put to make sure that your precedences do not get mixed up. We have discussed this in the early modules when we discussed about shortcomings of C and how C++ is better C. But with this macro I can do max AB, I can do max CD, different types. I do not need to specify anything, but it just textually replaces this code. This code is textually replaced here, and things work. So, it looks like a function, but as such it does not behave like a function, you know that. Right. So, for the same, if I macro, if I do this max A plus plus B plus plus, looking at this we will think that it will take the original value of A, original value of B and compute the maximum and give me the incremented values. But as it turns out, it actually gives, if I do max of 3 and 5, it actually gives 6. Why is that happening? Because it is textually replaced. We talked about this. It is textually replaced. Right? So, whichever is a larger value, for that the increment has already happened. Right? And finally, for the larger value 2 increments happen, because in the next time when you have actually chosen the value, that at that point also, so you had 2 A plus pluses happening if A is larger, right, or 2 happening if B is larger. So, this is a major pitfall, this is a major side effect. The other side effect is what will happen if I try to do it for a type for which this comparison operator is not appropriate. So, I have cat star S has 2 strings, and I have put black in one and white in the other, and I do the max. I have put white in there, black in there, I have just swapped the order in which I have put. You can see, if you just do the first one, you might think that it is working correctly, because you get white. But if you do the other, you will see that it is not working, it is giving you black. Why? Because this comparison is just comparing the pointer values, not the strcmp function, because you have no way of saying that. So, you have, if your comparison operator is something different from the basic built-in type operator, then also this solution is not going to work. So, it will not work for string, it will not work for any class that I define for myself, because the comparison for that class will not be known to the macro processor. So, this is where function template comes in. It is a parameterized definition, parameterized by the type, and it is prefixed by the keyword template. Right. And within, after that, after the function name, within a pair of angular brackets, you put the different types of type parameters that you want to put in. You can put in a type parameter by the keyword class or by the keyword type name. It is best to, instead of doing a theoretical discussion, it is best to look at an example. So, I am writing the max again. This is mandatory to tell the compiler that you are going to do a generative program. Then you put the type parameter with angular bracket. So, you are saying that T is a type. You say that by saying class. There is an alternate, you can say this by type name also. they are exactly the same, any one you can choose. Now, having put that, what T becomes, T is neither integer nor double nor my class nor complex, T is a type variable. So, here you are saying, so far we have dealt with value variables, where the type is known, the value is changing. Here the type itself is not known, I can give it a type. And then I say that my logic of max is, max takes two variables of the same type. So, let that type be T. It will return the maximum which is of the same type T, and this is my logic. X greater than y, then x, otherwise y. And what is this greater than? This has to be the greater than of the type T. So, it is here, it is not fixing the greater than comparison operator globally, it is just making it specific to the type T. We call it a trait of the type T. The trait of this type is it has a Boolean comparison operator greater than, which takes two values of this type and gives a bool result. Let us look at the use. So, integer variables, double variables, this is how you call the function. So, instead of calling it max AB, after max within corner brackets you provide the type. So, this becomes the value of T, T becomes equal to int. So, what the compiler does, when the compiler comes across this, compiler takes T as int and generates a code for max. Similarly, when you do for double, compiler takes T as double and generates a code for max where it is double. So, in this you can see that the compiler is automatically generating two overloaded versions of max, because I have asked to have a max for a type T which I have instantiated with type int in one context and type double in the other context. This is the notion of the generative programming. So, this is not the code that will run, but from this template of the code, a code for int will be generated for this case. From this template of the code, a code for double type will be generated in the second case, and they are overloaded and the appropriate one will be called. And now the compiler knows the type. So, the any kind of side effect that we thought of, that we could see, like in here in A++ we saw earlier in case of macros, will not be there, because it is a proper function. So, it will only take A and B as x and y having the type int. Right. So, one part of the problem of macro gets solved. The second was with the string. So, what I can do is, this is something very, very interesting again. We have provided this template. So, we are saying that for T this is the template, but if the type is char star, then I have a different template. If the type is char star, then I have a different template. Now, you will say that how can I have a template, because there is only one parameter T. So, if I say that parameter is char star, then everything in the code must be known. Yes, it is. So, it is not necessary that a template must have a type parameter. I can have a template without parameter also. So, what I have done in this case, I have specified explicitly that T is char star. I do that by writing the name of max in this way, as the way I was invoking. Therefore, this template has no separate type parameter. So, this type parameter is no more a parameter. So, therefore, it has a null type parameter list. And then using T as char star, I write the signature, and then I write the specific code where I can use this specialized comparison operator. Right. So, this is called this. So, what I have done is I have now there is this template itself can generate multiple overloads, int, double, and so on. And I have explicitly given a overload for it. So, if it is used with char star, this template will not be used for char star, because I have given a particular specialization. So, this feature is known as template specialization. So, if I give a generic template for a large number of types and specific templates for specific types which has a different handling, then I make use of the specialization. Here, since I had only one template parameter, the specialization is full. If I had 2 or more parameters, it is possible that I specialize on one parameter and retain the other parameters. Right? So, those are more complex examples. Once we have done this, then if we look at doing this with black and white and with white and black, if I do this max, now we will find that in both cases I get white, because actually this code is not being used, but this specialized code will be used, which rightly does the strcmp based on the pointed types and does the string comparison. Right. So, with this template specialization feature, we also circumvent the pitfall of C string comparison, which macros were giving us. So, we have in a way we have a lot of things solved. In terms of the template, I have the generator like the macro does in a weaker way. It is strongly typed, it behaves exactly like a function, and it can be specialized for certain types. The only somewhat pain remains in the syntax front, because I have to specify the type for which I am calling that function. Now, to a large extent, that pain can also be removed. That is, I can just, given this template, I can just call it as max. How does it work? Very simply, the parameters have types. So, the type of A is int, type of B is int, I know. Right? So, and I am trying to call max. So, in terms of calling max, I need to know the type T, and I know an int is expected here, an int is expected here. So, I can easily resolve that T has to be int for this whole call to succeed. Similarly, in this case, C and D are double. So, T has to be double for this to succeed. But if I call max A D, this call will not compile. Why? This is int, this is double. It needs both these types to be same, this particular template, they are different. So, what is the value of T? Is it int or is it double? No conversions allowed, nothing. It has to be exact, otherwise there will be a lot of confusion. So, the compiler will say that I am confused, I cannot decide. You have to tell me what to do. But okay, I say no. Comparing with integer double, my understanding is the comparison has to happen as a double. So, I say, so I get back to the explicit instantiation syntax and specify that I am looking for a double, function is double. So, T is taken as double. So, when A as an int is passed on, A as a parameter will be implicitly convert it to double and the function will work. But without explicit mention of that type, this is not logically resolvable. But at the same time, it is understandable that most often you would not need to do that. So, you can just use the implicit instantiation that is available from the compiler, and thereby you get the all benefits together. It looks just like a function, and you did not have to write it for every type, but it works for every type reasonably, and it can specialize for specific types and so on and so forth. It is a win all situation. So, this is some bit more of this. These are the different instantiations that you have. This is in the general, this is in the specialized. Now, what we provide by the name max, we provide yet another template, but with a different parameter signature. What does that call? What is that called? Overload. So, we are trying to overload the template. What do I just read into this template? It is saying, like before, it is saying class T. Then it says int size. This is a specific feature of template, that a template parameter could also be an integer, nothing else. You cannot have a char there or anything, but it can be an integer, wherein you can pass on a integral number. Why do I need that? Look at the intention carefully. So, class T size, and I am saying I want to do a max for x size. So, what is x? X must be an array. So, x is an array of elements of type T, and the array, if it is an array, I need to know what is the size it has got, right? And then it returns the. So, this also does a max, but in a different context. Earlier max was between two values, now it is between an array of numbers, but I want the same or very closely same signature to be there. I want the same name to be used. I do not want to call this array max or something different. Okay. So, these will easily bind, but if I try to do this max p val, then I will get an error. This will not compile. The reason is simple, is as you can understand that it needs to know the array as well as the size. In C++, the compile time defined size cannot be automatically passed along with the array. Array is just a pointer. It does not say how many are there. It's programmer's responsibility to remember that. So, it cannot resolve the size part, and it will give you an error. We will soon see how to get around with this. So, in terms of doing this kind of overloading, three kinds of conversions will be allowed. One is L value transformation, that is array to pointer kind of conversion, qualification conversion, and conversion to the base class instantiation from a class template. So, using these, you can actually create overloads of template functions and automatically, rather implicitly deduce the arguments, and we saw the pitfall where we were not able to deduce it implicitly. So, let us now try to do this max for a user defined class. Let me define the class complex with its constructor, its norm function, output streamer, and so on. I have a specialization here. I have a generic definition of the max here, and a specialization for char star. I want to use max for C1 and C2, two complex numbers. So, I have two ways. One is I can again specialize for complex and provide a different specialization. But I would like to actually do it smarter. I would like to use the general definition itself. So, but if I try, it will not compile, because it does not know how to compare these two. But for that, we have already discussed operator overloading. This operator overloading will solve this problem. So, what I have to do is, if I want complex numbers to be compared, naturally I have to provide the logic for that comparison, right. So, my logic here is their norms to be compared, whatever, you can give some other logic. But the basic point is, I must provide an operator greater than, a overload for operator greater than, which takes 2 complex and returns a bool. So, remember I had mentioned that this type T has a trait, its trait is it will have a operator greater than available, which takes 2 values of this type T and returns a boolean. So, if I want this max template to work for my defined class, I have to provide an overload for the comparison function. This in any case is logical, because I want to find a max, so I must know how to compare them. Even if I had to write a separate function for it, I would have required to kind of provide this algorithm for doing it, right. So, but by providing this, by making the class more self-sufficient and complete, I let the template code generator to generate code for my complex class. And so, for any user defined class that would want to use max, all that is required is satisfy that trait, provide the comparison operator, which you will need to obviously say for your class, you have to tell the algorithm, and with that you do not need to write any other max function. This template will do the entire job for you. So, you can see that how it makes it easy to reuse code at a kind of highest level and makes things really easy for us. In terms of the coming back to the overload question, we did see that this is one definition, this is a specialization, and this is the overload which we could not make work. Here I have just also provided the logic for it. So, this needs to be, this cannot be implicitly instantiated, because it needs to get both these, particularly a parameter size, which cannot be implicitly deduced by the compiler. So, for using this, the only additional pain we will have to bear is to do an explicit instantiation, that is specify that type, the type of the array, and the size. Here we have 1, 2, 3, 4, 5, 6, 7. 7. So, we specify the size 7. So, this becomes T, size becomes 7. So, here you are actually calling x 7 int, it becomes a valid parameter type and things will work. So, you can see that you can not only have multiple generative forms, specialized templates, you can also have overloads, and overloads again can have specializations. All of these are actually overloads that are automatically coming in as a part of the template mechanism. This is just to show the swapping function, very common swap function as a template. Mind you, I am writing this swap as capital S, because I am in the namespace std. Namespace std already has a provided swap function. If I do not use that namespace, then I can use the swap with lowercase. I just chose to use a different name. So, it takes reference to 2 objects of the same type, swaps them, does not return anything, and this is the swapping logic, which is clear. So, I can use this for 2 numbers, they will get swapped. I can use it for 2 strings, they will get swapped, and so on. This is easy to see. Now, the question is, what is the trait? What is the trait of this type T that I am using for swapping. That is, what are the properties this type must satisfy so that it can be used as a template instantiation type parameter. So, what are the things I am having to do? I am having to create a T temp, right. So, it must have a constructor, and that constructor must be default, because other than that, without a default constructor I cannot certainly make this code work. I cannot pass any parameter to that. So, it must have a default constructor and obviously corresponding destructor. Then I am making copies here. So, it must define a copy assignment operator. It must have a copy assignment operator. Otherwise, I might get into that deep copy, shallow copy issues. I do not know what are the types that you are. It may be a node structure which has a lot of pointers with allocated values. So, you may need to do some deep copy, right. But this copy assignment has to be supported. So, default constructor, destructor of course, and copy assignment operator. Without these, the swap cannot be used. So, that is the take back, that to be able to define the template, you must always identify what is the trait of the type that you are assuming. That trait will have to be satisfied, only then you will be able to use a type as a type parameter in that template instantiation. I said that template type parameter can be prefixed with the class or type name. In general, no differences. There is one context for the introduction of this type name keyword. There is a reason why the type name is given. Consider a template here. T is an unknown type, : name star p. What does this mean? What does this expression mean? Just observe that this expression can be interpreted in two ways logically correctly. One is, I can think that my T : name is a type. T is a type. Within that, I have defined, I have done some type def, I have another type. So, T : name could be a type. In that case, it is a pointer declaration. That is, this is a typical pointer star. In other words, it could also be that T : name is a variable, not a type in type T, and P is another variable. So, this basically is a multiplication. So, one is the conflict of understanding semantics is between a pointer declaration and a multiplication. Now, naturally, there is not enough information available on this line for the compiler to deduce. So, user has to provide, has to tell which one is this. So, what has been set in C++ is that if you just write this, this is T : name is taken to be a variable, and therefore, it is a multiplication, right. This is the default. If you want to mean that T : name is actually a type, you have to put the keyword type name before that. If you put the keyword type name before this T : name, then this will be treated as a type and it will not be treated as a multiplication. So, that is the specific context in which the type name keyword is required with a different behavior. You could not have used the keyword class, because that has, in this context, that has all different kinds of semantics already loaded. Otherwise, class and type name are exactly interchangeable in terms of the template parameter definitions. So, to summarize, we have introduced templates, the generic programming, meta programming in C++, and we have discussed the function template, that is how we can write very core algorithms in short function templates that can help generating a large number of overloaded function when I instantiate with different kind of types, and instantiation could be implicit as well. In some cases it must be explicit, and then based on that template arguments can be deduced. So, thank you very much for your attention. We will continue this in the next module discussing about class templates.